Hi everyone. In this video, we are going to learn how to multiply and divide using integers. Integers are a collection of all whole numbers, including positive whole numbers, negative whole numbers, and zero. And we have 6 learning objectives. So they all involve multiplication and divisions using integers. So let's look at them one by one. The first one, multiply integers. Let's look at some examples and to identify a pattern. Say each number starting from 4, 4, 3, 2, 1, 0, -1, -2, and so on. They are all multiplied by 2. When you multiply anything by 2, it's a double, right? Now let's look at the answers, the results. The first one is 8. Then from 4 to 3, we reduce it by 1. So the answer is 6. So answer is reduced by 2 from 8 to 6, right? Reduced by 2. Then we reduce the second factor by another one from 3 to 2. So the result goes from 6 to 4, again reduced by 2. Actually, it makes sense because from 3 to 2 reduced by 1, but it's multiplied by 2. So it's double the amount of reduction from the second factor. So let's continue from 2 to 1, reduced by another one, and the result reduced by 2. So far, we see the result always reduced by 2. Whenever we reduce by 1 in the second factor. So whenever second factor reduced by 1, the result reduced by 2. Now continue from 1 to 0, reduced by 1, from 2 to 0, reduced by 2. Now we want to reduce another one from 0 to -1. So -1 is 1 less than 0, right? And guess what? The result also should be reduced by 2, and it is. So from 0 to -2, -2 is 2 less than 0, right? Reduced by 2. And from -1, we want to reduce it by another 1, we get -2. We know -2 is 1 less than -1 because on the number line, -2 is to the left of -1. More importantly, for negative numbers, the bigger the size, the smaller the value. That is true. So we reduce by 1 again, we are going to reduce by 2 in the result. From -2 to -4 is reduced by 2. Now, here is a conclusion actually. When we multiply 2 numbers with different signs, one positive is negative, the result is negative. So when we do multiplication with integers, this is the conclusion. If the 2 integers have the different signs, the result will be a negative number. So let's look at this conclusion right here. When multiplying 2 numbers that have different signs, the product is negative. Now, here's another question. What if we multiply 2 negative numbers? So let's look at this example, this demonstration again. And see, notice that this time we multiply -2 for all of these examples. Again, we are going to detect a pattern by looking at this second factor in multiplication. Each time we reduce it by 1. So from 4 to 3, reduced by 1, and the result is increased by 2. From -8 to -6, that's increased. That's increased. Since for negative numbers, the smaller the size, the bigger the value. So let's continue from 3 to 2, that's another reduction by 1, and the result is another increase by 2. Reduce 1, increase by 2. From 0, we reduce 1, we reach -1. The value again increased by 2, from 0 to 2. From -1 to -2 is a reduction of 1 again. From 2 to 4 is increased by 2. So this pattern holds for throughout all of these examples. Now, this is the part that we want to focus on. When we multiply two negative numbers, the result is positive. See, this is also true. And this is from the previous conclusion. We already know that when you multiply two numbers with different signs, the result is negative. And here's a new conclusion. When you multiply two numbers, two negative numbers, the result is positive. And we already know positive number multiplied positive number is positive result, right? Like 2 times 5 equals 10. So this is our conclusion regarding multiplying two numbers with the same sign, no matter both numbers are positive or negative. When multiplying two numbers that have the same sign, that means both positive or both negative, and the product is positive. So that's our conclusion. Now let's use these conclusions, do some examples. And the first one, we have two questions actually. The first one, we have -2 times -3 times -4. And we already know that two negative numbers multiply together, the product going to be positive. So imagine this is a positive number and we multiply another negative number. So positive number times negative number will be negative. So we know the result will be negative. Now we just multiply numbers together without sign. 2 times 3 is 6, 6 times 4, 24. So we get -24 in the end. And let's move on to the next one. And negative number times negative number, this is going to be positive. And multiply another negative number, going to be negative. So this should give us negative number. And negative times negative, positive again. So final answer will be positive. And the number itself will be 5, because 1 multiply anything won't change that. We still get a 5 in the end. So from here, you can see when you have odd number of negative numbers, the result is negative. When you have even number of negative numbers, the result is positive, because even number means every 2 negative numbers give you positive. So the result will be positive. And this is the conclusion. When multiplying signed numbers, you need to count the negative factors. By the way, factors are those numbers involved in multiplication. So all of the 3 are factors. All of these 4 numbers are factors. So the sign of the result, the sign of the product is determined by how many negative numbers are involved in the multiplication. And this is a conclusion. If there are an even number of negative numbers involved in your multiplication, the product will be positive. If there are an odd number of negative numbers involved in the calculation, in the multiplication, the product is negative. Now, let's look at some more examples. One, we don't have number outside the parentheses. In algebra, if you don't have a number inside, outside the parentheses, it really means 1. So this one actually is -1 times parentheses, whatever inside, -8. So negative times negative will be positive, right? So next time when you see something like this, you just look at it as a negative. So the result is positive. Same thing here. This is, let me write it out. Everything that without 1 really means there is 1 hidden. So -1 times parentheses, -1 times parentheses, -10. So that's what we actually have. So we know we have our number of negative numbers. The result will be negative, right? And the number is 10. So next time, if we see a row of these negative signs, you just count how many. 1, 2, 3. 3 is number. The answer is negative for multiplication. Now, this is your first set of exercise questions. You have 2 of this. And remember, all of the answers to the exercise questions in these videos is in the comment area below the video. Now, let's look at our second topic. We want to evaluate, that means do the calculation. We want to evaluate numbers in exponential form. So we want to calculate exponential operations. Now, let's look at our example. We have 2 of this. The first one is -5 to the power of 2. We can also say -5 square. The operation, exponential operation, really means you multiply this base. This 5 is called the base. And this 2 is called exponent. So the meaning of exponential operation is that you multiply this base, whatever it is, by itself this many times. In this case, we multiply -5 by itself 2 times. So we know negative times negative is positive, right? So answer is 25. Following the same logic, we want to multiply this base -2 3 times. We have all negative numbers. The result will be negative. So 2 times 2 times 2, that's 8. So -8 is the final answer. Now your second set of exercise questions here. Let's look at the next page. Example 4. We have another evaluation problem, -3 to the power of 4. Now notice that this time we don't have the parentheses to surround this -3. We know for an exponential operation, we multiply the base this many times indicated by the exponent, right? But what is the base in this case? Without parentheses. Without parentheses, actually only 3 is the base. Negative sign is not part of it. It's not part of the base. So we are not going to multiply -3 by itself 4 times. So essentially, this negative sign is like equivalent to -1 times 3 to the 4th power. If -3 was the base, it would be written as something like -3 parentheses to the power of 4. In this, -3 is the base. We are going to multiply -3 by itself 4 times, but this is not the case. So this really means -1 times 3 multiplied by itself 4 times. And this gives us 81. So the final answer is -81. So conclusion is that without parentheses, negative sign is not part of the base. What you need to do is do 3 to the power of 4, which is 81, and just carry this negative sign over. So the final answer is -81. Now, more exercise questions here. Now let's look at our next topic, how to divide with integers. Let's jump this table. In general, the rule in terms of how to determine the sign of the quotient is very similar to those in multiplication. So let's look at this table. Say 5 times 3 equals 50. Basically, division and multiplication are opposite operations. So we have 2 numbers, 2 factors multiplied together equal to the product. In order to find one of these factors, you need to divide by the other factor. As indicated in the second column. Say if I use 15 divided by 3, one factor, I get the other factor. So 15 divided by 3 equals 5. Now in the next example, it is also true. So if I use -42 divided by say -7, I get the other factor. So -2, -42 divided by -7, the result is 6. So conclusion is that when you do division, and whenever these two numbers involved in division have the same sign, no matter both positive or both negative, say both are positive number, both are negative number, and the result is positive. Just like when we do multiplication, when two numbers in multiplication are both positive or negative, the result is positive. So they have same rule basically. Now let's look at the other two examples. -3 times -2 times 3, -6. So if we use -6 divided by one of this factor, we get the other one. So if we divide by 3 and -2, if we divide by -2, we will get +3 either way. Now same thing for the other example. We use 20 divided by -5, we get -4, right? Divided by one factor to get the other factor. But what is the conclusion in terms of the sign of the quotient? Division result is called quotient. So both involve two numbers with different signs. If you look at the answer, they all are negative numbers. So this is our conclusion, or you can say this is the rule when we perform division. When dividing two numbers that have different signs, the result, the quotient, will be a negative number, just like in multiplication. Okay, this is the formal writing of those rules or conclusion. When multiplying or dividing two numbers, they have same rules. If they have the same sign, the result is positive. If they have different signs, the result is negative. Another example, let's do this calculations. Negative divided by positive, the result is negative, right? So -5. Negative divided by negative, the result is positive. Oh, I don't know why I wrote 3. Oh, it is 3. Sorry. That's my eyes. -15 divided by 0, we cannot divide by 0. So this is called undefined. We cannot perform this operation. If this were equation, we would say this equation has no solution. Now another set of exercise questions. Our next topic is solving some equations containing a unknown factor. So let's look at them. The first one, 9x equals -63. We want to solve x, we want to get rid of 9. And to get rid of 9, you will do the opposite operation. What is the opposite operation? 9 and x are connected by multiplication. So opposite operation of multiplication is division. Whenever you do anything to an equation, do it on both sides to keep equation equal. So see, this is a hidden multiplication here. 9 divided by 9 is 1. We get 1x. 1x is x. That's why we divide by the number in front of this variable to cancel it. On the other side, negative divided by positive, that's negative. So answer is -7. Whenever we want to check our answer after we solve an equation, we just plug this number back in to see if both sides equal to each other. In this case, -7 times 9, that is -63. So -7 is the correct answer. We do the other two in a very similar way. This time we divide by -30. Again, these two connected by multiplication. -30 multiplied by y, we want to divide by -30. And in other words, regardless the number in front of variable is positive or negative, we always divide by itself to cancel it, because only a number divided by itself will give you +1. So you need to have 1y. So 1y is just y. Negative divided by negative is positive. So answer is 2. Next one, In order to get rid of 0, we would have to divide by 0, just like in the previous two questions, right? But we cannot divide by 0. And this equation, we don't say it is undefined. We just say no solution. Apparently, this is the correct answer because no number 1 multiplied by 0 will give you something other than 0. There's no solution. Our next objective is evaluate square roots. First of all, we want to understand what is a square root. Square root actually is a number or numbers. 1 multiplied by itself will be equal to the given number. Again, the square root of a given number is a number or numbers. 1 multiplied by itself is equal to the original given number. So let's look at some definitions. Rules for square roots basically says positive number will have 2 square roots. One is positive, one is negative. And a negative number doesn't have a real number square root. Later on, we are going to explain what is a real number square root. So let's look at some square roots questions. Find all square roots of each number. So the first number is positive number. And by the definition, we need a number 1 multiplied by itself equals 81. So what number multiplied by itself equals 81? That is 9. This number is small enough, we can see that. So 9 is one of the square roots. And there's another one, because 9 times 9 equals to 81. By definition, 9 is one of our answers. But we all know that one negative number times negative number is also positive. So as a result, negative 9 times negative 9 is also positive 81. So negative 9 is also our root. So we have 2 square roots for 81. And for this second one, there's no answer for this one because we are looking for a number, that number multiplied by itself equals negative 16. We know no matter positive number or negative number, whenever multiplied by itself, it will be a positive number. Positive number times positive number equals a positive number. Negative number times negative number is also equal to a positive number. There's no way when you multiply 2 numbers by itself, means those 2 numbers are the same. And you get a positive, you get a negative number. So there's no solution here. But we see no real solution, no real roots. The reason we see real roots is that at a higher level, mathematics have another system called a complex number system. In that system, we do have rules for negative numbers. That's why in here, we don't say no roots. We say no real number roots. Okay. Now, actually, there is a symbol to indicate we need to perform square root operation. And that symbol looks like this. It's the same as division. So for example, let's do this example 7. This one says, find the square root of 144. And we know 144 is a positive number. We are going to have 2 roots. And if you know which number multiplied by itself, so the 144, you can write the answer directly. Otherwise, you can always use a calculator to do that. And let's do this one. Pretend I don't know the answer for the square root of 144. So I just use my calculator. This is my square root button. And 144. Now let me close my parentheses. Equals, say I get 12. That means 12 times 12 equals 144. So 12 is our root. So A square root of 144 equals 12. So 12 times 12 equals 144. But we all know that negative 12 times negative 12 is also 144. So negative 12 is also our root. It's also our answer. But why I don't get this negative 12 from calculator? Why I did exactly this operation? I get a positive 12, but I didn't get negative 12. Why? The reason is that any positive number only has a positive root, actually. It is called a principal root. Why this one is not coming out of calculator? This rule is based on the fact that no matter you have positive number or negative number, when multiplied by itself, you always get a positive result. So we just add this negative root as based on that fact. So the calculator only gives you the principal root, which is always positive number. In other words, a square root of positive number only has a positive number root. The negative number root is from the fact that negative number times itself also give you a positive result. It's not direct result of doing this square root operation when you use a calculator. Now let's look at B. We have two roots. Look at B. We have negative square root of 9. So we know 3 times 3 is 9. So this square root operation, if you use calculator, you only get negative 3, right? Since we already have negative sign in front of it, maybe I made mistakes. I say negative 3. Negative 3 is final answer. So when you use the calculator to do the square root of 9, you get a positive 3. But we have negative sign in front of it. You just carry it over because this negative sign really is negative 1 times square root of 9. Just carry it over. You may say, hey, square root of 9 has two roots, positive 3, negative 3, right? And this negative sign indicates we just want that negative root. Okay, now C, square root of negative 36. There's no number in real number system that will give you 1 multiplied by itself, that will give you a negative result. So this one has no solution. We say no real roots. Now, here's another set of exercise questions. For next topic, we're going to solve some application problems involving these two operations, multiplication or division with integers. So on example 8 is on the next page. We have two of these application problems. The first one, let's do the first one first. Jean was traveling for 3 months. Each month, while she was away, $19 in finance charges was posted to her account. So she got charged by $19 each month while she was away. What were her total finance charges upon her return? In other words, after 3 months, because she was traveling for 3 months, after 3 months, how much in total was the finance charge? So basically, each month she got charged $19, $19, another $19, another $19. Apparently, that's multiple of $19, and that's why they need to do multiplication. So the total charge equals $19 times 3 equals $57 charge. Now, here's the thing. You need to mention this word charge. Otherwise, since it's a positive number, some people would think this is not charge. This is maybe a credit. Charge is taking your money away, right? If you don't write this one, then you need to write this 19 in negative number, using negative number. So negative $19 times 3, the answer is negative 57. When people say negative sign in front of dollar amount, they automatically know either this is the debit, the deficit, or this is the charge. Okay. B, Rick's total debt is $12,600. To pay off the debt, he makes equal monthly payments for 5 years. Remember, this is the monthly payment. 5 years means 60 months. Question, what is his monthly payment? So he keep doing this monthly payment for 60 months. We will ask to find out the amount for each month. So basically, from common sense, you spread or split this 12,600 total debt among those 60 months. We want to know how much each month, right? So this is the typical meaning of deviation. Let's look at this analogy here. 10 divided by 5 equals 2. What does it mean really? So deviation, one of the meanings of deviation is that you divide the first number into this many parts, the result is 1 part. So you divide 10 into 5 equal parts, the result is 1 part, 2 is 1 part. We know that makes sense. In this case, Rick will divide this total debt into 60 equal parts, right? 60 months. So we want to know monthly payment, that's 1 part. This is the exact same scenario. 5 parts, 60 parts, we need to divide by 60. So 12,600 divided by 60 months, we get $1 per month. So let's use a calculator this time. I guess it's 210, but let's not make some silly mistake. 12,600 and divided by 60. Yeah, 210. $210 a month. Then you can answer a question. Usually we need to answer a question in the formal way since this application problems. And say Rick's monthly debt payment is $121. This is the end of the video. See you in the next one.